Yeah, welcome to my today's talk, Getting Started with ReactPHP. And in particular, we're trying to push real-time data here as part of what can be done with ReactPHP. So let's see what you guys can expect today. We'll start with a quick introduction about what ReactPHP is. We'll start with looking into the core components, which is the event loop, the streaming data, sockets. Yeah, we seem to have some video issues. Promises, real-time data, streaming HTTP chatbots, interactive desktop GUI, and conclusions. So this is what we need to learn in order to understand what ReactPHP is really about. And to be honest, of course, that's not going to work out in 45 minutes. So what we are going to do today, let's hope it gets better. What we are going to do is we're just going to give you all the information you need to get started. So with this information, you can then use Google and see what you're interested in. So what we're trying to do is we're pushing real-time data to the browser. So this is what we are after here. And I encourage feedback. I also hope that we still have some time for QA at the very end. And let's see. So this is the actual agenda. We'll try to give a short introduction and then look just at the core components of ReactPHP. And really the main part of this talk is really about examples and demo time. So this means two things. A lot of this talk is about examples and live demos tend to go wrong. So please bear with me in case anything goes wrong. And B, this means if you have a laptop or a smartphone in range, you're invited to join the demos and use my live chat examples and hopefully don't mess with it. Okay. So let's start with a quick hello. Yeah, you can just see every second slide apparently, but you get the idea. Yeah, okay. I mean, maybe it works if I don't touch the device at all. Let's see. So, who am I? My name is Christian Lück, and there's this strange character in my name. And that's why I usually end up like this, even today, in 2019. So I usually go with a UE in my last name, and if you look real close at my name, you'll see that my initials, I'm not touching the device, that my initials make up for the word clue, which is my GitHub handle. So if you want to see any of the examples live and download the source code, this is how you can reach me. Also, if you want to tweet about this talk or want to reach out to me later on, I didn't have as much luck on Twitter, so my handle is another clue on Twitter, just in case you want to reach out. Okay, so what I want you to know about me is I'm passionate about what I'm doing. I'm standing here because I think ReactPHP is an important thing to be aware of. And in fact, this actually means that 2 years ago I quit my regular job in order to become a freelance software engineer. So this is now what I do for a living, teaching people how to use certain software architecture tools, such as ReactPHP. Okay, so much about me. Now, who are you? Who here considers themselves a PHP developer, software architect? Just raise your hands, just so I get an understanding. Okay, pretty much everybody, which is a good thing, because this is the IPC after all, the International PHP Conference, so I guess that makes sense. So who here has heard about React, the one with this logo? Pretty much everybody. So, which is interesting because you're going to learn something new today, because this talk is not about this React, and we'll see in a moment. So, but first, let's talk about how PHP is traditionally used. And when we talk about PHP, it's pretty much still the same thing like it was invented in the 90s. So, and this means this is still what most people think of when we talk about PHP. You have your client accessing your PHP through a web server, talking to some database. And of course, you have some frameworks, etc. But that's still the basic idea. And it means you're still bound in this pretty much traditional LAMP stack. And you always have this request-response cycle, which means a client is going to send a request, which is going to traverse over this architecture, eventually end up in your database, you get the right data, and send it back to your client. And of course, one of the common criticisms PHP receives is that it's too slow. But of course, if we take a look at this very traditional setup, of course we can improve this. So as an example, instead of using just a single PHP process, we can use PHP FPM. Here we go. In order to spawn multiple PHP processes, for example, we can use Nginx instead of Apache. And for example, we can use a caching daemon to offload work from the database to make our site faster. And what this really means is I mean, let's be honest, PHP may not be pretty, but somehow it still gets the job done. And this is why we are all using PHP. So something can't be that wrong about PHP. And we'll see. But nowadays, knock knock, who's there? Now we have the year 2019, and that means we now have entirely different requirements. So for example, we have separation of concerns. We have dedicated front end, dedicated back end. We have communication going on in between. We use HTTP APIs, RESTful, GraphQL, you name it. And we talked a lot of third-party applications. So a lot of communication is going on nowadays. It's not just this single server hosting your whole application. And also you might have some live data. You might have CLI tools such as Composer or PHP Unit. This wasn't really a thing in the 90s, but nowadays it's pretty much everywhere. In this talk, I want to focus on these live data examples. How can we use it? And one common idea is, let's just use Node.js. And this is a PHP conference, but let's be honest, it's a good fit. You can use Node.js. If you're happy with Node.js, go with it. I don't mind. It's a nice project. It has very interesting concepts. It has a huge ecosystem of third-party libraries, so you can pretty much build everything. You don't have to build anything from scratch. And but then again, there's this thing called npm install. And I mean, I don't really want to go into the details, but we all know keeping an npm installation or a project stable over a longer period of time can be tricky. I'm not saying it's impossible but it's a different ecosystem than PHP. It has many problems that PHP doesn't have in its ecosystem. It's a very huge ecosystem, but it's also very fragile. So, if you guys use Node.js, what I always try to get across here is if you just take a look at the word Node.js, it's okay to use Node.js, but also if you look really close at the name, what I always wonder, and I'm really sorry if you guys like Node.js or are in love with it, but the name literally says Node.js. And this is what I suggest today. Let's see if we can avoid using JavaScript and do the same thing in a different language. And of course, which language would we use? Of course, we would use everybody's favorite language. And this joke is really hard to tell on a non-PHP conference, but I think nobody even laughed about it on a PHP conference. So let's use everybody's favorite language, PHP, because honestly, it gets the job done. We've seen this. We all use PHP in our everyday work. It has very widespread usage, so it's pretty much everywhere. And also, to be honest, if PHP can do it, every other language should be able to do it. So what I want to get across here, it's not really about the language. It's more about what you can do with it and how you use it. So let's enter React. Okay. So we've briefly mentioned React before, but in this talk, what I want to talk about is ReactPHP. And when people hear React and ReactPHP, I want to make sure that you understand this is not the other React, as some people might call it, but to me it's actually the real React. Because honestly, we had the name first a few years before Facebook came, but well, Facebook has slightly bigger marketing budget than our open source project. So yeah, time will tell if people start calling this the real React, so you should keep this in mind. Okay, if you want to learn all about the details about ReactPHP, you can always check out the homepage. And today I'm just going to focus on some particular examples. So, a quick introduction. What is React? In short words, ReactPHP is non-blocking I/O, it's event-driven, and it's asynchronous. So these are all the buzzwords that you have to care about. And in other words, it's 100% pure PHP. It requires no extension, so you can use it on any installation, and also it's no magic, which means you might have to do something slightly different in order to take advantage of it. So what does that mean? Let's take a look. The idea behind ReactPHP is actually quite simple. So it's really simple. The idea is calculations are very fast, so your CPU is very fast, but in comparison, whenever you're doing an input-output operation, it's very slow in comparison. And the problem really is input-output is everywhere. So, for example, it's kind of obvious. Nowadays we have these requirements when we talk to a different third-party API, whatever protocol we use, but it's still sending something across the network, and we know this takes some time. For example, also when we talk to our local database, if it's in a remote data center or our own host, it's still communication with this database, so we have to wait for this. And we know the database might be slow depending on how much data and what kind of query you send. And also, when we talk to the file system, and we might not even notice, for example, when we use session files, PHP's default handling, it will store files on the file system. It's still input-output operations. And even if we try to avoid many of these things by using a caching daemon such as Redis or memcache, it's still input-output to the caching daemon. I mean, the caching daemon might be fast, but it's still input-output operations. And just so you can get an understanding, don't worry, you don't have to see every single number. But the basic idea is, what you can see at the top, this is what happens inside your CPU. So this is really fast. It's measured in sub-nanoseconds. And when you send something across the ocean, this is a whole different magnitude, right? It's taking way longer, millions of times longer. And this is why input-output operations are so slow. And it's not going to change anytime soon, because this is really bound by the speed of light. And it's unlikely this is going to change anytime soon. So there's no way to make your data travel any faster if it needs a long distance. And the conclusion here is input-output is slow. It's not going to change. We just have to face this fact. But why wait? I mean, we can work with this idea and just say, okay, we accept the fact that it is slow, but let's just do something else instead of waiting. And this is React. In other words, you can use ReactPHP to start multiple input-output operations, such as a file download, and then you can get notification when something interesting happens. So, for example, some new data arrived, part of your file arrived. And this means you don't have to waste any time waiting, unless, of course, you want to wait for something. So this is what React is and what React is not. It's not black magic, it's not voodoo, so it's not just something you magically install and everything suddenly becomes 10 times faster. That's not how it works, unfortunately. And also, it's not a new framework, which means this is not just something you install, like Symfony is part of your stack and you just use it. It's something that involves a whole new paradigm how you use PHP and your existing application. And also, it's not the new bus. So this is not something I invented last weekend. This is that's in production for now more than 6 years, and it has millions of installations. So I think it's important for you to know about it and see if it makes sense for your use case. Okay, so much for the quick introduction. Now comes the interesting part. How does it look in code? What do the core components do? So one of the first components we have to learn is the event loop. And as a consumer, when you first work with the event loop, pretty much the only thing you have to know about it is it's just the core of your application. It's just there. You don't have to care about it. It's pretty much everywhere, and it means you just create an instance once, you just pass it around through your whole application, at the very end of your application, you just run it. And in code, this might look like this, just as a quick example. So you use a factory to create it, you do something in the middle, this is the interesting part that we're going to look at, and then you run your application. What the loop can do from an implementer side, it has the name for a reason, because it implements a reactor pattern, which is also where we got the name from. And you can use it to start timers. So in code, this could look like this. And this example, it's kind of obvious what this would do, but still, let's see if we can run this on the command line. So we can run the same thing. We can run it on the command line. We see hello world, which isn't too surprising, to be honest. But what we can see is we actually started the world first and then the hello, and we can see it actually schedules it in the right order because we had this timeout variable, which is pretty similar to what we use in Node.js or JavaScript when we start an interval. So, and of course, we can also start periodic timers. So, for example, we can run it like this. This is going to print a number of outputs, and eventually it stops, because this is what my program is supposed to do. And interestingly, when we take a look at this example, we can also see how long is this program going to run. We can see the first timer waits for 0.3 seconds and the other one 0.5 seconds. So we can see it's not supposed to run for 0.8 seconds, but it actually only runs for 0.5 seconds, because this is the maximum interval. And once it's ready, it just stops executing. And this is all taken care of. And you can also use the event loop to work with underlying readable and writable streams, which is pretty low level, so we'll not get into this, because as an alternative, we can also use a higher level API for streaming data. When we talk about streams, if you have ever worked with Node.js streams, it's pretty much the same idea. If we talk about a stream, it's an abstraction for something that is too large to fit into memory. So for example, think about downloading a large file. If it's just an HTML file, it probably makes sense to store it in memory, but if it's a Linux image file, maybe it doesn't make sense to store a gigabyte in memory. So usually you just fraction it into small chunks, and you just process one chunk at a time. And this means when we talk about streams, you can either read from a stream, such as a download, you can write to a stream, such as an upload, for example, or there can be duplex streams, which means they are both readable and writable, such as a network connection. And this means this package provides a number of interfaces and events. And for example, it could look like this, which is a pretty simple example. It's still doing pretty much the same thing that we saw earlier. And in this example, we can see how it reacts to a data event on the input stream, which is what I type on the console. And then when data arrives, it does something. And we just forwarded this to the output stream, which is our console. So again, we can execute this. And now if I type hi, I can see an uppercase version of the same word, because this is what my program does right now. So we can see how we can use this to build interactive programs. For example, I could now use some if-else statements to maybe run some interactive chatbot-like application. And of course, one of the really powerful things about this is an abstraction that is used throughout ReactPHP's whole ecosystem. So just as an example, we don't have to get into what every single thing here means, but you still get the idea, I think. You can read from some source stream, you pipe it into something like unzipping it, pipe it into something like filtering some bad words from it, and then forwarding it to a destination. And this makes it a really powerful feature, because this is used throughout the whole ecosystem of ReactPHP components. Yes, so much for streams. And one of the things that makes streams more interesting is to actually talk to it. So we can also talk over the network, which means let's look into sockets. So sockets, if you've never worked with sockets, the basic thing you have to understand is pretty much just streams, but over the network. That's it. So that means you can use it in order to create a server that listens for connection to receive data, or you can create a client that connects to remote sites, such as HTTP, send a request to Google, for example. And in this talk, I'm going to focus just on TCP, but ReactPHP also provides UDP and other low-level networking protocols if you really care about it. And as a quick example, this is what it could look like. This is a sample server application written in pure PHP with no external extensions and installation required. So in this example, even if you've never worked with it, I still think you can get the idea. It's pretty similar to the previous example. Whenever you get a new connection, you get this connection object, and on this connection object, you get a data event. So every time somebody sends data your way, you can react to it. And in this example, I'm just going to write the data to my output stream, which is my console. And just to make this slightly more interesting, the next thing we can do, this will only send the data to the console, so nobody is able to see it. We can, of course, also receive the data and then just iterate over all open connection and send it back to every connection, which means this is pretty much all we need for a chat application. And I want to show you this in the command line. So again, let's just run the socket server. So now if you have a laptop in range, you can use Telnet to connect to this example. Just use this host name and the port 8000. And I'm going to connect twice so you can actually see how it appears on multiple screens. Does anybody have a laptop in range and wants to connect, or I'm just going to chat with myself? I'm okay with this. And there we go. See, somebody actually sent a message. And this is going to be recorded, so please watch your words. And of course, I can also say something, hi IPC. I can see how it appears in every single window, and you should also see this on your screen if you're connected to this application. And this is really just a few lines of PHP code, which is why I think this is interesting. It's really just 5%. It's like 10 lines of PHP code. Okay, I'll just keep this running in the background and we'll see what happens to the chat example in the meantime. Yeah, enjoy. So I'll just open a new tab in the meantime, but we'll get back to this later on. Okay, so much for sockets. What this means is this is now how we can create a server side. Of course, we can also connect to an existing server. So, for example, we can send an outgoing HTTP request like this. So we can use a connector component to connect to Google on port 80, which is the HTTP port. We write something, which is an HTTP request. And whenever we get some data, we write it somewhere. In this example, it's just going to print the results of the HTTP response to my console. So let's take a look. And in fact, when I execute this, I just get an uppercase version of Google's HTML code, which isn't very interesting. But what is interesting is this is actually pretty low level. So let's talk about how we use this in practice, right? You don't really want to talk plain text HTTP over socket connection. This is not how you use your existing ecosystem of libraries. Instead, sockets are really just an implementation detail. It's not something you have to care about that much. Really, most of the time you use high-level protocols such as HTTP. You talk to your database, which is a binary protocol, but it's all just high-level protocols building on top of sockets. Also, on top of these high-level protocols, you usually use some high-level paradigm like RESTful or some RPC-like things. So this is what you usually care about, and it's all abstracted away in higher-level applications, which you can use, of course. And also, this is always or often abstracted away in pre-existing software development kits providing you APIs, which just means you get a library, you just call a function, and you don't really care about what's going on underneath. This is how you actually use it, which means the concepts still apply, but honestly, all the details are really hidden from a normal application. Okay, so much for sockets. Now let's get into promises. What is a promise? Who here has worked with promises before? Just raise your hands. Okay, around a third. So quick introduction into promise. When you've never worked with a promise, we actually use it in one of the previous examples, and we'll get into it, why this is so important. A promise is a placeholder for a result. And this means whenever you execute an operation, instead of waiting for the result, you just get a placeholder. And you can use this placeholder in order to be notified when the result is ready, which means this placeholder can be in 3 different states, essentially, which is just the short version here, which means it can either be still pending when it's not ready, eventually will get fulfilled with a successful result, or it might be rejected in case an exception occurs. And this is really all you have to care about when you're dealing with promises. Promises APIs can look like this. If you've ever worked with promises in JavaScript or pretty much any other language, you will feel immediately familiar with it because you just use the then function to register to it. So this means it's you no longer tell but ask for something. You say, when this is ready, then call my process function in this example, which would be just a function. You can also hook in a callback function or class method if you want. And you can either say the first argument is what happens when it's successful, and the second argument you can use when it's unsuccessful. So in this case, when it's successfully done, you process the result. When it fails, you just bar dump the exception trace or something. And again, this is just the introduction for Promise API, so let's see how we can actually use it. When we use this in an actual application, we can use it like this. We've seen how we can use low-level socket components to send an HTTP request, but of course, there's also an HTTP request, so this is a pretty common requirement, so of course there's an existing application, and this is what it looks like. If you've ever worked with Guzzle or Buzz, it's pretty much the same thing. You have get method, which means you send a get HTTP request, you pass in a URI, it's going to send a request, and eventually you get back a response. And in this example, I say, when this response is ready, then use this body and write it to the output. And of course, we can execute this. This is just a few lines of code. And of course, again, it's just going to print the same thing. So it's not, it's a higher level abstraction, so we don't have to care about all the underlying details. I can also measure how long it takes. So in this example, it takes around 0.13 seconds. So I can execute around 8 requests per second here on this Wi-Fi connection. And really, when you only use a single application, it's not really interesting to use a promise. But of course, if we can execute this operation once, we can of course also put this into loops. So just as an example, we can just wrap this in a for loop. And in this example, I'm just going to send 3 requests. And I think there are many applications where it makes sense to do some things multiple times. And now we can run the same thing again. Now it's this one. Now if you look real close at the output, you'll see that it actually is the body 3 times. And what's really interesting now is if we measure how long this takes, we can see that it's pretty much the same time. So we kind of expect this to take 3 times as long, but it's really one of the powerful features here is this is all asynchronous, non-blocking input-output operation. This is really what ReactPHP is good about. This is one of the core features of ReactPHP. You can pretty much do any number of things at the same time as long as it's input-output operations. And I think this is a really powerful feature because this is again used throughout ReactPHP's whole ecosystem. And you can use this to send GET requests, or you can send HTTP requests. You can talk to your database. We have adapters from any existing database. You can talk to your file system, pretty much anything. And you can do this at the same time without having to wait for it. And this example, I just have to wait for the latest or for the slowest response. And this is when my program exits. So this can be a huge difference in performance depending on how much remote parties, third parties you talk to. And again, promises in practice means promises are everywhere. So just as an example, we've actually seen how it's used in Socket. It's used in the HTTP client. We can use it for higher level applications, such as using a packages API, just as an example. We can also talk to Redis, for example. We can talk to our database. It's pretty much everywhere. So this list goes on and on. So much for promises. We've now seen how we can do multiple things at the same time. Now, let's see how we can use this in our HTTP setup, because we want to build a real-time system after all. Okay. So one of the first things before we get into HTTP streaming is I think we have to get a short introduction into HTTP. We've seen this before on the socket level, but essentially HTTP just means you create a connection to your remote site, so you connect to Google, and you pretty much just send get / which is your resource. And this is HTTP 1.1. It's a plain text protocol for HTTP 1. HTTP 2 uses a slightly more complicated binary protocol, but the same ideas still apply. It's just a different way to send these messages. So you send your request, and in response, you get back something that looks like this, as an example. I stripped off all the headers just to focus on the interesting details here. So for example, you could just tell us there's a plain response, and here's the body, hello world. Of course, that's not what Google is going to return, but it works for our examples, because it fits on a single slide. Okay, and of course, we also have an existing component. So we can use ReactPHP to create an HTTP server. And let's see. So we can now execute this. And of course, this is now running an actual HTTP server, which means how long is the HTTP server going to run? Of course, it's not supposed to quit, which is why this program just keeps running in the background. So you can now use your browser to actually access this site. So if you want to, you can use your favorite Chrome version to access this site. It's running on Workspace again. On port 8080 now. This example, I'm just going to use curl, and I get back the expected result, hello world. So this means this is now a fully functional HTTP server written in pure PHP. So I don't have Apache Nginx installed, nothing. It's just PHP. And I think this is really powerful because it means we don't have to care about the whole ecosystem. And this is actually surprisingly performant. But this is not the topic of this talk, but I really invite you to check out the benchmarks, because this is going to be much faster than your existing Nginx application using FPM, etc. I've actually run some benchmarks a few years ago, which means that my single laptop was able to outperform the Google Cloud in printing hello world. Yeah. Which is not to say that cloud systems don't make sense, but maybe you don't have a requirement to use such sophisticated applications after all. So this is what HTTP looks like. When we talk about HTTP streaming, it's still pretty much the same thing. So it means when we talk about streaming things, it's still HTTP, right? So the same semantics still apply. We still send a request, we still get a response. So what does streaming really mean? It means different things depending on who you talk to. So as an example, it could mean you stream a download, right? If you're downloading this very large image file, maybe it doesn't make sense to wait for the whole thing to be ready, but you just wait for each chunk to arrive. And likewise, you can also stream upload. So if you're uploading a very large file, maybe it makes sense to not store this file in memory and just use it as a streaming way. And we've seen how we can use streams on the console and pretty much any other higher-level component. And this means this is still request response. So this is what it could look like in ReactPHP. We've seen how we can use the HTTP server. In this example, I'm still going to use the HTTP server. And if I hit a certain path, so the root path, in this example, I'm just going to return the same response. But now instead of actually using a string value, I now use a stream. And this stream is just a through stream, and you can see how we use a periodic timer. So this is like the combination of the previous examples. I just use a periodic timer to send something to the stream every once in a while. And after a certain time, I want to cancel this because I don't want the stream to go on forever. And now what's interesting here is this is really just a plain text example. So of course, this is just going to print hello, 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 which is not that interesting. But let's see why I think this can be a very powerful feature. So now instead of run the same example, now I just use curl. And I can see how it prints out hello in the given interval. And you can, of course, use an actual web browser if you want. You're going to see a white page with some black font on it. And this is just everything you need in order to stream. And what this means is, of course, in this example, it's a plain text stream, right? It's just going to use this through stream to send some actual data. But because streams are everywhere, it also means you can talk to pretty much anything. So instead of using this single stream which you have control over, this could also be something that's coming from a remote system. So for example, you could have a stream giving you all the details that happen on Redis. So for example, you use Redis pub/sub channels, or if you use an event-driven system like WebSocket connection or something, you can use an existing stream and you process this data as soon as it arrives, and you can send this off over HTTP with just the plain text components. So you don't have to set up any fancy measures to access this data. So, and of course, when we talk about HTTP streaming, there are ways to work around it. So long polling or commit might be a way, which is something you probably shouldn't be using nowadays anymore, but that's how you can use HTTP streaming. So this was the introduction to HTTP streaming. So let's see how we can actually use this in our browser, because I don't want to see a white page with some black text appearing on it. I want to actually work with the data and react to it on my front end. Okay, so who has worked with event source before? Hands up? No hands. Interesting. Not a single one. So what I find interesting is when we talk about event source, the alternative name is server-sent events. Anybody? Yeah, single hand, finally. Okay, so what's interesting is this is something that's built into your browser around the same time that WebSockets was invented, and pretty much everybody's used WebSockets, but for some reason nobody's using event source. So the idea behind event source is really simple. It's still normal HTTP, so you have a normal request response cycle, but you have a client API on your browser. So every recent browser, which means every single vendor except everything that comes from Redmond, supports it. In case you want to use Microsoft Internet Explorer Edge, you can use a polyfill. And this means this is built into your browser. And this is what it looks like. Essentially, it's normal HTTP. So you send a request, and what you get back is just a normal HTTP response. We've seen this before. It's 200 OK. It has a special content type. And now you get something that just says in plain text, data, colon, and then there's your data. So it means this is how you can get some data, and the interesting thing is this connection actually keeps open, so it means at a later point in time, over the same connection, you might get another data event. And I think this is where it gets interesting, because this means you now have a persistent connection to your remote server and can use this connection to send any kind of data. And what I also find interesting from a networking perspective here is this is normal HTTP, right? You don't have to learn a different protocol. It's not a binary format like WebSockets. You don't have to read 20-page RFC. It's really just prepending data colon in front of it. So this shouldn't be too hard. And of course it's not. We can use this to build our own example. So we've seen how we can use streaming data to just send something to curl or a plain text HTTP connection. And of course, we can just wrap this in a through stream. In this example, it just means this through stream has a filter function, so it modifies the data while it flows through it and just prefixes your data with this data colon thing. So it means every time you write something to the body, it actually prints it as data colon and then your actual data. And I'm losing my microphone. Okay. So this is what it could look like, and we can execute this on the command line. And there we go, which means we can now use our web browser to actually access this site. So on port 8080, which means you can also use your favorite web browser to access this site. You can also check out the source code, which is really just a very simple file. So by no means, I don't consider myself a JavaScript expert, but I think this is how you use JavaScript nowadays. You don't have any external dependencies, nothing. You just use this event source object, and you just pass an URL, which is your site that streams the data, and whenever it reports a message, you do something with this. And this example, I'm just going to append it to the body. So it means if you have this open, you're going to see every single message that the server emits. But how do you emit stuff to the server? In this example, my server is using the existing chat application that is still running in the background, which means if you send something to the chat example, it should appear in this window. And we can just try this. So it means if I use telnet on port 8000 and just type hi, right, you can see how it appears in the background. And this is pretty much immediately, because this is all reactive. And this is just a single PHP file, which is why I think this is a really powerful feature. So you don't have any external things. And yeah, this is still a live demo, so you can mess with this if you want to. Okay, so again, I'll just keep this running. You can use this as a chat example. In this example, what I wanted to focus on is just the bare basics here. Of course, this is not how you would use it. In a more useful application, of course, you wouldn't use a chat example, just printing something to a white page with some black font. Of course, you would use some JavaScript frontend to process your messages, right? We've seen how we can use this message event on the JavaScript side. And of course, don't just think of it as a chat. I think of it as a way to transport structured data. So instead of sending plain text data, you could as well just send JSON messages. And I think this can be a really powerful feature if you talk about many different applications, such as notifying your users something happened on your site. A new blog post appeared maybe, or if you have an e-commerce system, maybe your availability of some things changed, so now you have only 2 items in your stock. You can use this as a way to transport any kind of structured data in a really simple way. Yeah. And let's keep this running in the background. So get back to the slides. There we go. So this is a fully functional HTTP server in a single PHP file. And of course, what this means, this is just a very quick introduction to it. There are many, many third-party projects you can use with ReactPHP. I encourage you to check out the existing wiki, which we use to list some of the application. It currently has, I think, 150 projects listed on this page. And on packages, we have more than 300 projects building on ReactPHP, which I think is really, really interesting. So just check it out if you want to see how you can talk to your remote systems. If you don't want to use a plain text chat, maybe you can use one of the existing components. Okay. And of course, it means I would love to introduce so many more different applications that I can use, and I always use this screenshot because this is what you can actually do with PHP. You can also build graphical user interface application with just plain PHP if you want to, and I really think, is this how you want to proceed? I think this is really representative of how you can use it. There are so many ways how you can talk to a third. Any kind of application, if you think about it, it's really oftentimes just sending something to it and receiving something from it. So let's get to the conclusions because we're running out of time. What I want you to take away from it is, now, can I use ReactPHP to make my website 1,000 times faster? This is a question we receive as ReactPHP quite frequently. And I think this is an interesting question. And let's just think about it for a moment. We've seen how we can use this to stream multiple things at the same time. So my answer to this question is, of course, yes, you can use this if you want to make your site 1,000 times faster. But I think you're really missing the point. This is not what ReactPHP is about. It is about doing multiple input-output operations at the same time. And if you have an application where you do this a lot, then it makes a whole lot of sense to use ReactPHP. If you only want to use your existing application and just want to make it faster and you don't want to touch any of this existing code, don't use ReactPHP. So let's recap here. What I want you to take away. PHP is way faster than you probably thought. So I encourage you to check out the benchmarks. It's probably going to outperform many of the existing architectures. This is not how people expect PHP to behave. So I think this is really interesting. It's also far more versatile. You can use this not just to build your next web application, but you can actually use this to build a command line application. You can build this to run a daemon. You can build this. You can use this to build a database if you want. And people actually do this. This is not just something I came up in a fever dream or something. This is how people actually use it, and it's really powerful, and it works in production. And when we talk about ReactPHP in particular, I want you to take away, this is a real deal. It's here to stay. It's not. It's a stable thing. You can use it. It's production ready. People have been using this in production for years, and if I may say this as a maintainer of this project, I think it's awesome, and I really think it is. So I encourage you, just give it a try. Try it out. And I think you should try it out whenever you have an application that has to wait for something. And in particular, this means whenever you access the network. And I think many of the existing applications access network in a way. Your database, HTTP, you name it. So if you need any help with this, you can check out the elaborate documentation on our web page. As an alternative, you can also reach out to our team on ReactPHP. You can use the ReactPHP hash or handle. And of course, you can talk to me, because did I mention I'm a software engineer? This is what I do for a living. I'm available. So if you want to talk about this, just reach out. So thank you for your attention, and that's it.